I welcome you again to the UNU-INWEH public event, the Science Talk. I am your host, distinguished speaker. Will be an interactive Q&A session and we'll have for comment, Q&A, and any other contributions that you may have. Please type your questions or comments in the Q&A chat box, and we will pick them up from there afterwards. Thank you. The topic of today's talk is monitoring environmental data to improve integrated watershed management. And our presenter is Dr. Kelly Munkitri. I hope I got that right.
That was good.
All right. Dr. Kelly is a Canada Research Chair in Aquatic Ecosystem Health Assessment at the Department of Biological Sciences at the first UNU hub, University of Calgary, here in Canada. Its research background is in aquatic toxicology, fisheries ecology, and the development of environmental monitoring programs. Dr. Kelly is an academic. He's a co-founder of the Canadian River Institute, was the scientific director of the Canadian Water Network, and he sat on scientific panels on many international bodies, for instance, the Great Lakes Fisheries Commission. He has developed regional monitoring programs in South America, Asia, and North America, and has worked with various governments to improve environmental assessment models and has taught environmental monitoring study design in more than a dozen countries. Without further ado, help me in welcoming this morning for the Science Talk, Dr. Kelly Munkitri. So Kelly, I hope you're feeling good. Over to you.
Okay. Thanks, Grace, and thanks for the invitation to give this presentation today on an approach to improving how we can do integrated watershed management. When I'm giving a talk to, especially when there's international attendees, I like to start by acknowledging that prior to European colonization of Canada, there was a lot of First Nations that existed within Canada. And Canada is going through a process of reconciliation to reestablish and try and work better with our First Nations partners. And we start our talks as part of this with a recognition of the land that we work on. And the University of Calgary acknowledges and pays tribute to the traditional territories of the peoples of Treaty 7, which include the Blackfoot Confederacy, comprised of the Siksika, the Piikani, and the Kainai First Nations, the Tsuut'ina First Nation, and the Stoney Nakoda, including the Chiniki, Bearspaw, and Goodstoney First Nations. And the city of Calgary is also home to the Métis Nation of Alberta, Districts 5 and 6. I recognize that integrated watershed management includes economic and societal considerations, but I'm going to focus today on the environment and talk about trying to improve transparency, clarity, and confidence in decision-making relating to environmental impacts, recognizing environment's only one component of management. Most jurisdictions conduct some sort of regular water quality sampling. Very few use the information effectively. There's a couple of different types, either accumulated state monitoring or status and trends, which follow changes over time. At best, the information gets incorporated into state environment reports. And at worst, it tracks environmental degradation without intervention. There's a unique aspect of Canadian environmental regulation for international people who may be sitting in, our dominant piece of environmental legislation up until the mid-1980s was the Fisheries Act, which was originally written in 1867 as one of the foundational acts of formation of Canada. Fisheries Act is still a dominant piece of our environmental regulation, and it recognizes that there's a priority in the aquatic systems for protecting fish, fish habitat, and use of fish. So there's a lot of emphasis in Canada on monitoring fish, benthic invertebrate communities as an indicator of fish habitat, and then contaminant levels in fish as an indicator of the ability to use fish. Industry does a lot of monitoring associated with their activities, and I divide that monitoring into 5 different types: compliance monitoring, crisis and spill management monitoring, mitigation effectiveness monitoring, performance monitoring, and environmental effects monitoring. And I'll talk about environmental effects monitoring in a bit more detail in a minute. I'm going to just touch real quickly on the oil sands in Alberta. This is a map of the oil sands on the right, and you can see Alberta within the context of Canada on the left. The oil sands represent the 3rd richest oil reserve in the world, and the bitumen that's there is a mixture of clay, sand, and oil, which is extracted with hot water. And the current production is about 3.3 million barrels a day. Around 2010, 2011, Europe labeled the Canadian oil dirty oil. And at that point, the federal government stepped into the situation in Alberta and told the industry that they were going to take over regional environmental monitoring. And together with the province of Alberta, they demanded that the oil sands companies pay $50 million a year to support regional environmental monitoring. Started out as the Joint Canada-Alberta Oil Sands Monitoring Program, JOSM, and then after 3 years went to be just oil sands monitoring. I took 5 years off from academia starting in 2013, and I worked with 17 of the oil sands companies to try and align monitoring with the new regional framework. I was part of the team in 2011 that put together the new framework. And then I went to work with the companies to try and align the monitoring they did. The first question I asked, I had when I started, it was 13 companies, and I had 13 senior monitoring people from each of the oil companies on a committee that worked with me. And I asked them, first question was, tell me all the monitoring that your company does, and now that you give $50 million to the government to take over some of it, what do you think should stop? And I found out that none of the companies could tell me all of the monitoring they did. It wasn't centralized within a company structure. It took us 18 months to come up with an inventory, and we calculated or estimated that the companies were spending $180 million a year monitoring across 74 different types of monitoring programs. I mentioned the existing monitoring with industry does. The regional monitoring, there's a new type there called cumulative effects monitoring. I'll come back to later. There's also monitoring associated with proposed developments, with environmental impact assessment development, with cumulative effects assessment, and with environmental risk assessment, which go into the environmental impact assessment process. So in total here, we have 11 different types of monitoring that go on in many basins. And there's no common framework, philosophy, methodology, linkages, database, and no common regulatory basis. And the failure to integrate monitoring into cumulative effects management systems results in a considerable loss of integration and inefficiencies in the use of monitoring activity. I'm going to talk a little bit more about 2 types of these that can be used to try and improve integrated management. The first is environmental effects monitoring. Prior to moving to academia, I worked for 11 years for our federal government, and I was part of the team that developed our environmental effects monitoring requirements in the early 1990s. And EEM is a regulated, mandatory, industry-funded cyclical monitoring program that was designed to answer whether when a facility is in compliance with the discharge regulations, whether the receiving environment's associated with environmental impacts on fish, benthic invertebrates, or fish use. It's required under the Fisheries Act for major sector-wide regulations, and it's continuing to be developed for new sectors. Oh, it's a tired program. It's not a tired program. It's a tiered program that operates through some people think it's tired. It's a tiered program that operates through different levels of activity and intensity, a surveillance level. If you see a change, you go to confirmation. If you see no change and you confirm it, you can skip a cycle, which we call minimal monitoring. If you see a change, you confirm it, and it's of sufficient magnitude, you go into extended magnitude to describe how big an area is changing. And if it's of sufficient concern, you go to investigation of cause, which is usually a research-based study, and then to investigation of solutions. Lots of challenges. Monitoring's simple, but the philosophy can be complicated and differences can be subtle. So people use the same words to mean very different things. All effects are cumulative effects, and organisms exhibit the integrated response to all stressors. If I've got a sewage effluent, I've got waste heat, I've got ammonia, I've got nutrients, I've got pharmaceuticals, I've got personal care products, I've got microplastics. In a city, I've got stormwater plus municipal wastewater plus industrial wastewater. Organisms integrate all of those responses, and so all effects really are cumulative effects. Monitoring can be stressor-based, values-based, or effects-based. EEM is an effects-based monitoring program. Some jurisdictions in Canada require an aquatic effects monitoring program, an AEMP. It differs from EEM, and this emphasizes that the philosophy can be complicated and differences can be subtle. An environmental effects monitoring program asks, when a facility is in compliance, is the receiving environment showing changes from anything? It could be upstream, it could be cumulative. AEMP asks the question, does this facility cause a change in a receiving environment? Very different question, very subtle difference, but very large differences in how you design the program. Designs feel restricted by the absence of baseline data. This is a picture of me 40 years ago as I was starting my research career. My master's program was conducted out of a fish cancer lab. We worked in Hamilton Harbor, which is, for those of you that know Canada, Toronto, Lake Ontario, Hamilton's down here where Hamilton Harbor is. Two large steel mills that in the 60s and 70s employed about 40,000 people and discharged their waste into Hamilton Harbor. When we set nets in Hamilton Harbor, there were 3 abundant species of fish we caught, and all 3 had cancer. This is a brown bullhead with a lip papilloma, a melanoma, and its whiskers burnt off. This is a carp with a gonadal tumor. This is a sucker with a liver tumor. No, it's a sucker liver with a tumor. That can be sustainable. Kelly defines sustainability as the next generation should inherit an environment at least as good or as bad as the current one. I can't control how we got here. The best I can hope for is to make sure that future generations don't get an environment worse than this. The challenge is it's totally unacceptable to have only 3 species when there should be more than 50 and they should be healthier. And so I separate the concepts of sustainability and acceptability. Restoration is a question of acceptability, and sustainability is related to degradation. The priority has to be to stop degradation and then consider restoration, and the study designs are very different. But it means that establishing the current or a recent baseline is critical for monitoring. I don't need to know right now what the baseline used to be pre-colonization or 50 years ago or 20 years ago. I need to establish what is the situation now and is it changing? So baselines are interpreted differently by different groups. The reference baseline represents the information you use for comparison to detect a change. And in most programs, it represents the initial phases of data collection if data does not already exist. While we'd all like to know the historic baseline, it's not always known, and it's usually an aspirational state, not explicitly defined, and the goal for an unacceptable condition should be restoration and progress towards an aspirational historical baseline state. So the current situation degrading is unsustainable. The current situation getting better is working towards restoration. So when I see change, I try to define that change and to separate expected from unexpected. If I put in a sewage treatment plant, I may have an expectation that nutrient levels are going to go up slightly in the river. I want to separate whether the change is stable or getting worse. Expected change that is stable is less of a concern than unexpected change that's getting worse. And change which is stable is a question of acceptability. Does someone have to fix it? Change which is getting worse is a question of sustainability. At some time or at some level, degradation is likely to affect something important. Then I want to know, is it site specific, local, or regional? How big an area is changing? In a cyclical monitoring program, these evaluations should happen at regular intervals. Under the EEM program, it's typically a 3-year cycle. And statistical difference should not define what a change is. This is data from a 30-year study we did on Lake Superior, which is a very clean area in Northern Ontario. This is at a reference site where there's no permanent residents, no discharges of any type. And this is the size of ovaries in female white sucker when they come into the streams to spawn. And if there's a red asterisk, it means that the difference was statistically significantly different from the year before. And so more than 50% of the time, we see statistical differences between years when nothing's happening. This is data from the first 20-some years of that program on just a body mass index for fish, just showing that the mean is 1.31, standard deviation is 0.12. Statistical difference is a function of sample size. The standard deviation in randomly selected members of a population will stabilize after about 12 individuals. And so if I have 12 fish, I can detect a difference in this endpoint of 0.14. If I have 100 fish, I can detect a difference of 0.048. And with 3,500 fish, which is in this data set, I can detect a difference of 0.008. So statistical difference is just a function of effort. If I go out and collect enough animals or samples, I'll be able to find a statistical difference. The difference that we see here, the red lines are 2 standard deviations of the entire data set, and it's what we use if you don't have sufficient data as an estimate of what a meaningful change is. So I don't start to really worry until a change gets bigger than 2 standard deviations. But if I see a statistical difference, I still want to keep my finger on the pulse and I still want to look at it. But the critical effect size is how big a difference you want to be able to detect. So that we use triggers to move between tiers of effort. And the trigger is how big a change will mean I'm concerned enough to increase my monitoring or enter some sort of assessment or investigation of cause. And responses that surpass a pre-designed target response level act as a warning signal that monitoring needs to increase the development of an assessment process. And the focus of triggers is to find a target that means the environment is protected and the situation is sustainable. So that there's a difference with effects-based approaches like EEM. You have to define the target that means the environment is protected, and continued degradation in any measure is unsustainable. You have to accept that impacts and sustainability can coexist. If you measure at a sensitive enough level or sufficiently large sample size, you will detect effects that are sustainable. But once you see them, you can track them. You need to separate detecting differences from interpreting the significance. The job of monitoring, one of the challenges we get with monitoring committees is they all want to be regulators. And the job of monitoring is to provide regulators with the information and decision makers with the information they need to make decisions. Ongoing monitoring and adaptive management are needed because any decisions about sustainability or acceptability have an expiry date. If I have 3 dry years or 3 wet years or a new development comes in, or a new species comes in, the situation may change. So EM is an adaptive monitoring system that operates through cycles. Surveillance, are there changes? If my difference is beyond a critical effect size threshold, I go to confirmation. If I confirm them and it's beyond the critical effect size, I go to focused monitoring. If the change is across a sufficient area or of a sufficient magnitude or is getting worse, I go to investigation of cause. And so it's a tiered and triggered adaptive monitoring system. I spent 14 years at the University of New Brunswick, and we did an assessment. This is the St. John River, which forms the border in northern New Brunswick between Canada and the US. The upper part of the basin is in Maine. It's about 650 kilometers long, and each of these dots represents a study site. Between 1999 and 2011, we had 115 graduate students working on the river system on everything from water quality to paraphyton to bugs to fish, and trying to identify areas of concern within the river basin. In the late 2000s, 4 major developments came into the basin. The top one is a molybdenum mine that started into an EIA process. The one to the east here is an expansion of potash mining. The oil refinery in St. John had a proposal to double its production, and the city of St. John was putting in new secondary sewage treatment systems. They all had an EIA process. None of them used a single piece of data that we had from any of our 115 studies. So we entered into a 3-year study with EIA scientists to ask them, why is what we do so useless for what you do? This is an example data set. This happens to be the size of baby sculpin, which are a small fish that's very territorial. And this is, as you come down a river system from industrial forest plantations into the potato farming area, this is the size of this year's baby fish in August. And you can see in the potato farming area, in the downstream, such as the river, they're about 6 times the size they are in the forested river. All of our data sets in our studies looked like this, trying to identify change, trying to identify impacts. All of this information was useless for the development of EIA predictions. And it took us a long time to figure out why. We were working with Lauren Gregg and Peter Dunker, who are 2 EIA scientists. I kept showing them data set after data set, and they kept saying, I can't use that. I can't use that. And then we showed them this data set, and they said, that's the first useful thing you've shown us. This is the size of these baby sculpin in the end of August against what the maximum temperature was in the streams that summer. And the traditional approach to doing environmental health assessment is similar to what you get when you see a physician. You go in and you get your blood pressure taken or your cholesterol taken. They compare what's normal for your age and gender, and your physician tells you you're healthy if there's an absence of signs that you were sick. So our approach in New Brunswick was going to rivers. We would expect in a clean site at the end of August, 30 to 70% of our fish would be this year's babies, and that they would be somewhere between 25 and 45 millimeters in length. Once you get this kind of a regression, what the EIA scientists pointed out is if we know that the temperature this year was 17 degrees, we can actually figure out if the fish are the size we expect them to be. And so when you take an 8-month-old infant to a physician, they don't take its blood pressure. They say your infant's in the 85th percentile for the length and weight that we would expect it to be at this age. And so this really changed our philosophy on environmental monitoring. And if we understand what environmental factors or operations are driving the variability between years, you can transition monitoring from a retrospective focus, has it changed, to a predictive mode. Is this year's level what I thought it would be? And that's what we call cumulative effects monitoring. It's a check on our knowledge of the system. If our predictions are wrong, we don't know what we think we know, and we need to learn and adjust in an adaptive way. If in the next 5 years, the fish look like this, the system's operating normally. You'd want to have a number of these kinds of relationships. The next 5 years, the temperature has shifted, but we haven't broken anything that we can tell with this relationship. And if it falls off the line, then something has changed and we don't understand the system as well as we think. So it changes monitoring to observed minus expected and explicitly links monitoring and modeling in a feedback loop. So it changed our strategy for environmental monitoring. I mentioned that most current approaches follow a human medical paradigm, which asks, is your parameter within its normal range of variability? And where we want to go is a performance-based assessment. Are you performing within the normal range of what we would expect given the stage of development? Is this particular parameter responding as predicted by EIAs or by modeling what we know of the stressor pathway? This means there needs to be tighter linkage between modeling and monitoring, and we need a better understanding of what's driving variability. If something is changing in proximity to developed sites, what's driving that change? And so here we have two cycles. We have an adaptive monitoring cycle where we go out and we monitor and we analyze, we compare it to a monitoring trigger, conduct an assessment, and we adjust our monitoring if we need to. And the same data goes into a modeling cycle where we have a forecast trigger, which is how big a change we would expect to see based on this year's conditions. And if it's outside of that forecast trigger, we need to go into an adaptive modeling cycle. And the ultimate goal is a cycle of feedback between modeling cycles and monitoring cycles that iteratively improves both. This figure shows where we were in 2010 in terms of trying to understand what roles monitoring played in support of cumulative effects assessment. The monitoring can tell you the current accumulated state. It can help form the model that's being developed to make predictions, and it can track the observed future state so that you can understand if your model is functioning properly. So cumulative effects assessment, we used to say, Monique Dubé and I published a paper back in 2001 that said when we do our normal type of health assessment, it's a retrospective cumulative effects assessment, and an EIA is a predictive cumulative effects assessment. Those two processes should talk to one another. The work that we did on the St. John River changed the philosophy of monitoring so that we could make those two processes talk. And it focuses now on what aspects you want to monitor, the aspects of the environment that are different in good years and bad years, and embrace that variability. And understanding the variability allows you to make predictions. Understanding change at site-specific, local, and regional levels using standardized triggers and a tiered approach can provide testable hypotheses, logical next steps, and the focus needed to provide actionable outcomes. In an ideal world, the model used environmental risk assessment would make forecasts of expected deviations from the reference state based on levels of stressors and make a prediction of whether post-development there would be an increase, no change, or decrease in a stressor of concern. The terminology around cumulative effects assessment is complex. All effects are essentially cumulative effects, and cumulative effects assessment means many different things to many different people. Cumulative effects management is composed of a cumulative effects evaluation cycle, which requires the development of a cumulative effects predictive model, the use of that model for scenario forecasts, and a process of cumulative effects assessment. If I'm building a sewage treatment plant, I want to do a bunch of modeling that will tell me if I put in no treatment, what does the river look like? If I put in an aerated lagoon, what does the receiving environment look like? If I put in activated sludge, what does it look like? If I put in tertiary treatment, what does it look like? And we could model those various scenarios as part of the EIA process and come up with a selection of an optimal scenario in the development of a predicted future state to give us a forecast. It links back to adaptive monitoring through the interpretation of the current accumulated state in an accumulated state assessment. and the development of an environmental effects monitoring program to define when the predicted forecast is not achieved. And it links to adaptive management through the use of model predictions and forecasts to provide the information needed to inform regional vision plans and management frameworks in a linked management cycle. It operates on a slower time scale. My adaptive monitoring should be operating in a very rapid phase so that my monitoring from this year informs what monitoring I will do next cycle. Regional planning, regional frameworks operate on a slower time scale, 10 or 20 years to make changes to those. And so now I've got a third cycle. I've got an adaptive monitoring cycle. The same data is linked into my adaptive modeling cycle, and it's now linked to an adaptive management cycle. So I've got three types of triggers: a monitoring trigger, a forecast trigger, and a management trigger. And forecast triggers need to take information from monitoring to signify when forecast conditions or model assumptions have changed, or monitoring shows the observed conditions are outside of the range predicted in the forecast. Adaptive monitoring needs to provide the accumulated environmental state and signal the cumulative effects evaluation cycle when there's a change in the forecast or an exceedance of a management trigger, which would trigger the adaptive management cycle. The adaptive management cycle could be triggered either by an exceedance of a management trigger or a change in the forecast because assumptions of previous modeling and planning are not being met. So there's different types of thresholds. We want the monitoring trigger to be when we're seeing change in the variability. We don't want it set where the management trigger is. So in this case, we're monitoring every 3 years on our indicator. If it goes outside of normal, it triggers faster analysis, accelerated monitoring, accelerated effort. If it was an expected change and it stabilizes, I'm not as concerned as if it was an unexpected change or continues to get worse. Holy cow, my tongue is tied. And so we need some space between the management trigger and the monitoring trigger to allow us to respond before we need to change regional plans, policies, and regulations. If you think along an adverse outcome pathway, you want time to mitigate change before you have to alter these other processes. So I've got 5 cycles in reality. I've got my monitoring cycle, my management cycle, my modeling cycle. I've got a performance cycle that runs at the facility level based on engineering or development predictions. And that runs a process of continuous improvement for the facility. And then I have a compliance cycle from regulations and policies that the regulator uses to limit the conditions of any discharges. So an integrated watershed management system is different than an adaptive management cycle. An adaptive management cycle is focused on a specific management action to mitigate an identified problem. An adaptive tiered and triggered EEM program is the engine that drives an integrated regional management system. All data can be put into one database with predefined triggers to adjust monitoring, confirm modeling, trigger policy and planning updates, alter regulatory strategies, and run continuous improvement processes. It doesn't cost that much to run, but you do have to make a priori decisions about what is important, how big a change you want to detect, and how big a change will alter management, and commit to sharing and integrating the data. This is just the actors in a regional system: regulators, planners, modelers, regional monitoring, site-specific monitoring, and developers. And everybody requires something from somebody else. The developer requires from the regulator compliance limits, the existing vision and management triggers from the planners, existing conceptual models and the forecast from the modeler, needs existing baseline monitoring requirements and sites from regional monitoring. It needs to develop its own site-specific monitoring plan and its continuous improvement cycle. And it needs to provide to the monitoring site-specific issues, forecast and trajectory, needs regional monitoring to be provided, the sites to be added to the network and adjustments to the conceptual model, to the modelers, any adjustments to the conceptual model, to the planners, potential changes to forecast future trajectory, and to the regulator, the environmental impact assessment and performance projections. What we haven't done yet is figured out how Indigenous communities and rights fit into the decision-making process. What would a row and a column look like for Indigenous participation in the system? Public stakeholders have roles in the planning process, in developing of the plans and expectations and vision for the basin. But Indigenous communities and rights holders fit into this decision-making process in a way that's yet to be defined. So I'm happy to stop there and answer any questions.
Thank you, Dr. Kelly. It takes a bit of processing, actually, but the first thing that jumps to mind is I'm wondering the effect of climate changes, given how fast sometimes this happens, many a times you don't even see it coming that much, from one day to the next, you're having this, for instance, flood, so how does that dynamics, changes this logic?
Well, it becomes part of the key in the modeling component is to understand what drives the variability between years, and changing temperature, changing flow are two of the dominant things that drive that between year variability. So it would be incorporated into your forecast trigger in terms of making a prediction about what next year should look like. In most systems we've looked at, flow and temperature are the largest drivers of differences between years in your bugs and your fish. And if you can make predictions based on how the climate is changing, on how that change should look, then that gets into the cumulative effects monitoring, where you're looking at observed minus expected.
Okay.
Does that make sense?
Well, I think so. But again, what about the human dimension? You were talking about, these oil companies and all that, at times, I also want to recall, these accidents, one that happened not too long ago, where the ship, collided with a bridge, and it was quite catastrophic, so how do, where do those, unexpected, human dimension, factor into this logic?
Yeah, so that's part of the mitigation or crisis management, where it would trigger new monitoring. It's much like an adaptive management cycle monitoring. There would be, if there's something like an oil spill or an unplanned release, then there's lots of monitoring that gets triggered in that would be very specifically focused on those stressors. And so that's all part of the regional system. Right now, that crisis monitoring and the adaptive management monitoring are run under different processes. And that's part of the challenge with all of this, is that none of the monitoring really speaks to one another. It all operates independently, and the data all sits in different databases.
All right. I'll ask a follow-on question, but Alan is asking here, it seems like all monitoring programs are required to do a cost-benefit analysis. Has that been done with environmental effects monitoring in general, or is it even possible?
Environmental effects monitoring isn't incredibly expensive. And the Canadian program, if you ignore the toxicity testing component of it, it's about $50,000 to $80,000 once every 3 years. For a pulp mill, that works out to pennies on a ton of pulp. And for mines, it's a relatively small cost. One of the challenges we have in something like the St. John River, there's 25 licensed dischargers into the St. John River system. If each of them had a monitoring requirement that was linked, and they each had an upstream and a downstream station where they're just doing water quality and benthic invertebrates once every 3 years or 5 years, you'd be getting data on 50 stations in the basin that you can use to run a regional program for very little cost to any single facility.
Has any of these been implemented? So if so, I'm curious, how did you secure the buy-in of all the stakeholders?
Yeah, I can say that this is not, this is my, I call it my theory of everything. When I was working with industry, when the government changed and the NDP government came in Alberta, they kicked monitoring out of all discussions. And so I had 2 years when I was working with industry where I had time to think about how the system could be improved to try and do things better. We're doing a couple of pilot programs in a couple of places trying to implement aspects of this, but I can say that there has been no buy-in yet for people to do this. It requires people to fundamentally change how they look at things, how they share data, how they make decisions, and it's my aspirational theory of everything.
Okay. A follow-up to Grace's question. Martin is asking, how do you incorporate forecast uncertainty into the process, especially when the uncertainty may not be known? I mean, the unknown unknowns,
Well, so the advantage of environmental effects monitoring is that it makes no assumption. It's kind of a backstop for all other processes. The focus is to tell you whether there's an environmental concern. And so you have to decide. When we were developing it, the lawyers were very focused on us making sure that the result of monitoring, if you didn't see something, couldn't be, you had to go back and look harder. So we had to very intentionally define what kind of a change and how big of a change we would consider to be worth further discussion. So we never defined what an effect was. We defined what an effect wasn't. And in the case of fish, if you go out and get me 2 species of adult fish, 20 males and 20 females upstream, downstream, and I don't see any change in how fast they grow, how long they live, how many eggs they produce, how fat they are, how big their livers are, then I'm going to assume for now I don't have a major concern at this site. And so the environmental effects monitoring is meant as a backstop. If something is changing in the system, you're going to see a change in the water quality or the benthic invertebrates or the fish endpoints that will trigger you to go in and try and understand what is changing. So it's kind of a measurement of the pulse of the system. And so if something unanticipated is happening, or it's one of the challenges with EIAs, environmental impact assessments, pre-development, is that they're never 100% certain. There's always, when there's been a problem after development's occurred, it's been an unanticipated pathway, an unanticipated sensitivity, an unanticipated species, some unanticipated interaction. And so if we can't make the environmental assessment process perfect, what we have to do is make a monitoring system designed well enough that it detects changes quickly and allows you time to respond. And so the unknown unknowns is exactly what EEM, the question was specifically not, does this pulp mill still cause a problem when we discharge effluent? It was, do I see a problem in the receiving environment if this pulp mill is in compliance? And when we started with pulp and paper, we had 130 some pulp mills in Canada across the country. And what we wanted to know is, do we see the kinds of things we're concerned about at 80% of them or at 5% of them? And when we see those changes, do we see them most often when it's located next to a sewage treatment plant or next to a hydroelectric dam? Or so is it a cumulative thing that's happening, or is it something that we haven't identified? And so the intent of it really is to find those unknown unknowns. The known things, you can always design a specific stressor-based. I mentioned you can have an effects-based approach, a stressor-based approach, or a values-based approach. Communities want to know, can I drink the water? Can I eat the fish? That's a values-based approach. Stressor-based approach, if you know what the things are you're worried about, you can design specific monitoring for those. So any comprehensive monitoring program needs all 3 aspects. It needs your stressor base for your known knowns, your values based so that the communities are protected, and then your effects based, which is your backstop to detect unknowns.
Yeah. Before I ask others to also say something about this, I'm a firm believer of systems speaking to each other, but now I'm a bit worried, the broad effect of all this. Are scientists actually impacting? Because when we spend so much, so many years, a lot of thought process goes into things like this to make the world better and all that. And it seems the systems are not listening. The people you are trying to make things better for, they seems not to, we can't secure their buy-in. That seems to be a gap, so what do we do? How do we move from here to there?
Yeah, so when I teach my environmental monitoring design course, I've got 4 foundational things people have to accept before we start to talk about designing and monitoring. And the first and most important point is that environmental monitoring is a belief system. If you believe that you're being poisoned by the environment, there's no amount of data that's going to change your mind. It's like your favorite sports team or your favorite political party. No amount of data is going to change your mind. The only solution is to involve communities in the monitoring, to build the relationships, to build the trust, to build the capacity over time that people make their own decisions about the environment. And one of the things that I try to emphasize is that focus on existing and whether it's getting worse first. And then we can talk about what it used to be and how but if we don't stop it from getting worse, and we try and fix it, then we're wasting money because we haven't fixed the problem yet. So focus on here and now, focus on building trust relationships and community involvement, and let people make their own decisions and their own information as they become part of the process.
It's okay. Fatima is asking here, in the slide of baby scorpion, the fish size was bigger in the agricultural area. How do you interpret the change?
So that's one of the other challenges with monitoring is it's really easy to see change. It's really hard to understand why. In the agricultural area, the water was warmer, there were more nutrients, productivity was higher. We saw lots of other changes. There were decreases in nest density, decreases in fecundity. So there were lots of impacts, but you've got changes in temperature, changes in flow, changes in storm events. You've got changes in productivity. You've got changes with fungicides, herbicides, insecticides. It's really easy to go out and find change. It's really hard to figure out what is causing it and how do I fix it.
So are these not part of the stressors, monitoring stressors, triggers?
So the intent is to understand if the change is stable or getting worse, how big an area is changing, and then to try and zero in an iterative program to try and figure out what's causing those change. So we can go upstream or downstream till we get above the change or below the change and try and emphasize over time. So the adaptive monitoring process is meant to focus your resources where you have the most concern and on the issues that you have the most concern about. One of the challenges we have with long-term monitoring programs is they do the same thing forever and ever, and they don't adapt when they see something to try and focus in to understand what's happening.
Okay. Manzo, any question? Okay, Miriam. Miriam wants to ask a question. Go ahead.
And I was wondering if you have any data that's from citizen science groups or hobby groups, fisher groups, or if it's all, professional data.
No, there's certainly, so some of the programs that we're working on right now are trying to build the capacity in communities so that they can take over running the process. And one of the things about these triggers that we're trying to develop is trying to provide some decision-making capability to communities so that when they go out and do monitoring, they can figure out how big a concern they should have. But there's definitely a big role for community science in here, and especially for community involvement to try and get communities involved in the programs to help drive the system. We work in Calgary with a local group that is totally focused on community citizen science processes.
Are gender considerations included in this community aspect?
What was the question again?
Are gender considerations, factored in?
Absolutely. And that's one of the challenges we have is getting the funding to be able to adequately resource and fund those communities to participate effectively. And so in general, we try and let the communities select the people to be involved, but we hold public meetings in the communities where we hold an open house to talk about the program. In the north, especially in Canada, if we use the Northwest Territories as an example, for us to go out and do a monitoring program, we need both a research permit and a fish collector's permit. The local communities have vetoes on both of those permits. And if they don't feel adequately involved in the design and operation of those programs, then they can deny subsequent permits for you to go out and do the work. So there's a lot of effort to try and involve them intimately in the process. It's not the same all across Canada, but that's the direction that things are going.
Okay. Any more questions in-house? All right. I guess that's it. If more questions comes in, like I told you earlier, I'll collate them and send them to you. Thanks so much for your time and the valuable insight. And truly, I hope that all this will be implemented, because it makes so much sense for systems to speak to each other. I mean, we're talking about the same watershed, that a lot of all stakeholders depends on. So it just makes sense that we'll be able to secure the buy-in of all stakeholders, for the health, for planetary health, or how else we want to call it. So once again, I say thank you for your time and for the valuable information you provided through your presentation. So on behalf of everyone here, thank you.